Hello students, in this video I will go through exercise U5A07A where I will be applying concepts related to inverse, sine, cosine, and tangent functions to solve for unknown angles. Let's take a look. So the instructions here says find a measure of the indicated angle to the nearest degree. So in this exercise or in this video I'm just going to go through the even questions here just because they're all very similar. So question 2 here, I noticed that this angle is the angle that I'm trying to find. I'm going to use red. And I really have no restriction as to whether to use inverse sine, cosine, or tangent. So what I'm going to do for this first problem, I'm just going to use inverse tan. Okay, so inverse tan, so I'm going to call this angle here x. Okay, so arctangent of something, or actually, let me go back. Let me take a step back. Tangent of x is equal to, so the side opposite of x is 76. The side adjacent to x is 57. So therefore, to get the unknown angle, I'm going to take the inverse of both sides. X will equal to arctan of 76 over 57. So what I need to do then is I'm going to enter that into the calculator. So I'm going to go to the calculator. And make sure your calculator setting is in degree when you're doing this. So I'm going to press second tangent, 76 over 57. And that will be 53.13. The instruction set says here to round to the nearest degree. So you know what? Angle x is equal to 53 degrees. So angle x is equal to 53 degrees. And let's take a look at the next one here. Question 4. Again, I'm going to call this angle x. And here I'm not told what the third side is. I'm only given 2 out of the 3 sides, which means they are suggesting to you that they want you to use a specific trig ratio. So the ratio that we're going to use, 14 is opposite of x and 17 is the hypotenuse. So they want us to use sine. So sine of x is equal to 14 seventeenths. So therefore x will equal to arcsine of 14 seventeenths. And what exactly is that? So I'm going to go into my calculator. Arcsine of 14 seventeenths is equal to 55.439, but they want us to round to the nearest degree, so that would be angle x is 55 degrees. Okay. Again, very similar. I'm going to call this guy x. So sine of x, again, because 39 is opposite of x and 48 is the hypotenuse, so therefore I have a sine ratio. X is equal to arcsine of 39/48. And again, I'm going to figure this out. 39/48. So arcsine of 39/48. That would be 54 degrees, rounded to the nearest whole degree. All right. Question 8. So again, I'm going to call that angle x. So here in this case, 22 is adjacent to angle x. So I'm going to use cosine. It's 22 over 23, because 23 is the hypotenuse. X will therefore equal to arccosine of 22 over 23. And again, I go to my calculator, arccosine of 22 over 23. That would be 16.957, and that would be equivalent to 17 degrees to the nearest whole degree. And again, 2 is adjacent to, so again I have a cosine, so that would be 2/5. X is equal to arccosine of 2/5. Arccosine of 2/5 66 degrees. Number 12, 9 is opposite of x, and 17 is adjacent to, so I want to use tangent of x is equal to 9/17. So x is equal to arctan of 9/17. And what would that be equivalent to? Arctan of 9/17 is 28 degrees to the nearest whole degree. Again, tangent of x is equal to 16/43. So x is equivalent to arctan of 16/43. And that would be 20.4 or 20 degrees to the nearest whole degree. Number 16, x is opposite of 26 and 12 is the hypotenuse, so therefore I'm going to be using sine. Sine of 26 is equal to x over 12. Here I don't need to use the inverse sine function, so x is simply 12 sine of 26. And I punch this into the calculator. 12 sine of 26 is equivalent to 5.26. And they want us to round to the nearest tenth, so 5.3. Here again I have x is opposite of 43 and 10 is the hypotenuse, so sine of 43 is equal to x over 10. X therefore is 10 sine 43. So 10 sine of 43 is 6.8. And moving on, question 20. X is opposite of 25 and 12 is adjacent to, so tangent of 25 is equal to x over 12. X therefore is 12 tangent of 25. And what is that going to be equivalent to? 12 tangent of 25 is 5.595 or 5.6. Because to the nearest tenth. Next, I have 75 degrees and 10 is opposite of it, so I'm going to be using sine because I need to find out what the hypotenuse is. So sine of 75 is equivalent to 10 over x. Isolate x. X is equal to 10 over sine 75. And I'm going to punch that into the calculator. 10 divided by sine 75. That's 10.35 or 10.4 approximately. X is opposite of 37 and 10 is the hypotenuse, so sine of 37 is equal to x over 10, or x is equal to 10 sine 37. Punch that into the calculator. That would be 6.02 or just 6.0. And the last question for this batch, I need to isolate x. So I'm going to be using cosine because x is adjacent to 18. So cosine of 18 is equal to x over 11, or x is equal to 11 cosine of 18. Punch that into the calculator. 11 cosine 18. 10.46 or 10.5. 10.5. All right, last batch here. So it says here, find the length of the side labeled x, round intermediate values to the nearest tenth. Use the rounded values to calculate the next value. Round your final answer to the nearest tenth. So we need to find out what that missing side length is on x there. And notice that they drew a a dotted line right down the middle, and that's actually a hint as to, you know, the intermediate step that they were referring to. Let's call that H. We need to find out what H is, because then it will help us link to the because that side is being shared by the two triangles there. So H is going to be adjacent to 58 and 25 is opposite. So I'm going to be using tangent of 58 is equal to 25 over H. So therefore H is equal to 25 over tangent of 58. And that is approximately equal to 25 divided by tangent of 58. 15.6. They set to round to the nearest tenth. And since H is adjacent to 44, and I need to find out what X is, and X is the hypotenuse, I'm going to be using cosine. Cosine of 44 is equal to H over X. So X, therefore, is going to be H over cosine of 44, and I already know what H is. It's 15.6 over cosine. 15.6 is H, so 15.6 over cosine 44. I need to enter that into the calculator. 15.6 divided by cosine of 44. That is equivalent to 21.7. And the last problem here, I want to call that side there H. So H is opposite of 65, and 25 is the hypotenuse. So then I can say sine of 65 is equal to H over 25. H is 25 sine of 65. And from there, I can solve for what X is, because X is opposite of 54, and H is adjacent to 54. So I can say X over H is equal to tangent of 54. I need to figure out what H is, so I can substitute that into the second equation I wrote there. 25 sine 65, what is that? That is 22.7, because they set to round to the nearest tenth in the intermediate step. So X over 22.7 is equivalent to tangent of 54. X will therefore be 22.7 tangent of 54. And X will therefore equal to 31.2. And that's it.